All right, welcome back, everyone. Today we're going to talk about solving quadratic equations by factoring. In this lesson, you're going to learn the definition of a quadratic equation, how to solve quadratic equations using the zero factor property, and then how to solve factorable equations of degree greater than 2. So first of all, a quadratic equation is something that's written in the form ax squared plus bx plus c is equal to 0. Notice that it looks similar to our trinomial form, except for it has an equals 0 at the end. Right? We've taken these trinomials and turned them from expressions into equations. If we can factor this quadratic equation, if we can factor the left-hand side of this equation, then we can determine solutions. We can figure out values for x. And the way that we're going to do this is using what's called the zero factor property. So assume that you have two numbers, a and b, and you know that the product of those two numbers, a times b, is equal to 0. Well, if you've got two things multiplied together and they're equal to 0, then that means one of the two numbers has to be 0. So either a is equal to 0 or b is equal to 0. So whenever we factor a quadratic equation, we're left with two factors that are multiplied together. Remember, it's the reverse FOIL method. If the product of both of those factors is 0, then you can determine a solution to the equation by just setting each factor equal to 0. And so we're going to practice this for the remainder of the lesson. Here we want to solve this. X minus 3 times x plus 1 is equal to 0. Well, there's nothing to factor here because it's already factored. But if we want to figure out what's going to make this equation 0, we're just going to take each piece and set it equal to 0. And then solve. Here we're going to add 3 to both sides. And you get x equals 3. Here we'll subtract 1 from both sides, and you get x equals negative 1. And those are our two solutions. In general, a quadratic equation will have two solutions. So let's try another one. Same idea, x minus 5 times 2x minus 7 equals 0. And so we're just going to take each piece and set it equal to 0. Add 5 to both sides. X equals 5. Add 7 to both sides. You get 2x is equal to 7. Divide by 2. And you get x equals 7 halves. So now we have two solutions for this problem. Well, for those two examples, we didn't have to factor anything. We were just able to take the factors and set them equal to 0. For this example, we're going to have to factor the left-hand side first. So for now, forget about the equals 0 part. We're going to do just like we did in the past few sections. Take the first number and last number, multiply them together, you get negative 22. We're going to make a box, 1x and 1x. We now need two numbers that multiply to give you negative 22 and add to give you negative 9. Well, negative 11 and positive 2. And now we have our factored form, x minus 11 and x plus 2. And now we can bring back that equals 0. And just like we did in the previous examples, we're going to take each piece and set it equal to 0 and solve. So here we'll add 11 to both sides, and you get x equals 11. Here we subtract 2 from both sides, and you get x equals negative 2. Now you can check these by plugging those numbers into the original equation and seeing that 11 and negative 2 will give you 0. When you're solving quadratic equations in this way, if all of the terms are not on one side of the equation, you need to move them so that they are. So here we've got 4x squared minus 28x is equal to negative 49. Well, what we want to do is we want to add 49 to both sides. So that now we get 4x squared minus 28x plus 49 is equal to 0. We want everything on one side equals 0. So here there's no greatest common factor. And so again, we're going to take the first number and the last number and multiply them together. 4 times 49 is 196. Write the coefficient both times and split the variable. We now need two numbers that multiply to give you 196 and add to give you negative 28. Well, that would be negative 14 and negative 14. So again, we can reduce each side like a fraction. All of the factoring parts are exactly the same. You get 2x minus 7 and 2x minus 7 equals 0. Now we can take each piece and set it equal to 0. And hopefully you recognize that by solving one of these, you'll solve them both because they're the same thing. Divide both sides by 2 and you get x equals 7/2. This is one of the rare occasions when a quadratic equation only has one solution. And it's because you have two solutions, but both solutions are the same. Notice also that this trinomial that we factored was a perfect square trinomial. And that's why we wound up with the same answer twice at the bottom. So for this problem, remember that we need to have everything equal to 0. So we first have to expand and move some stuff around, and then we'll be able to solve it. So first, distribute the x. You're going to get 2x squared minus 7x is equal to 4. And then we're going to subtract 4 from both sides. And you get 2x squared minus 7x minus 4 equals 0. So again, take the first number and the last number, multiply them together. We're going to get negative 8. Now draw a box down here. Write the coefficient both times. Split the variable x and x. We now need two numbers that multiply to give you negative 8 and add to give you negative 7. Well, that would be negative 8 and positive 1. So again, we can reduce these like fractions. 2 will go into 2 one time. It'll go into 8 4 times. And you're left with x minus 4 times 2x plus 1 equals 0. And so now we'll take each piece and set them equal to 0. And so add 4 to both sides, and you get x equals 4. Subtract 1, divide by 2, and you get x equals negative 1/2. So if the highest power is greater than 2, factor as much as possible and then use that zero factor property to solve. So here we've got 3x cubed minus 12x. Well, they have a greatest common factor, and the greatest common factor is 3x. And what we're left with is x squared minus 4. And notice that x squared minus 4 is a difference of squares. And so we can rewrite this as 3x times x plus 2 and x minus 2. And all of that's equal to 0. So now, we still want to take each piece and set it equal to 0. Except now we have 3 pieces. We want to say 3x is equal to 0. X plus 2 is equal to 0, and x minus 2 is equal to 0. Well, for this one, if we divide by 3, you just get x equals 0. Here we subtract 2, and we get x equals negative 2. add 2 and you get x equals 2. And so for this problem, we have 3 solutions. Here we have a much bigger problem, but again, we just need to factor and then use the 0 factor property. 5x minus 1 is already a factor, so we can just leave that alone. We want to factor 2x squared plus 15x plus 18. So take the first number and the last number, multiply them together, and you get 36. Make ourselves a box, 2x and 2x. We now need 2 numbers that multiply to give you 36 and add to give you 15. So 12 and 3. We can then reduce each side like a fraction, 1 and 6. And so we get x plus 6 and 2x plus 3. And we've got to bring down that first factor, 5x minus 1. And now we can just take each piece and set it equal to 0 and solve. Plus 1, divide by 5. So x equals 1/5. Subtract 6, and so x equals negative 6. And then subtract 3. And divide by 2. And x equals negative 3/2. So again, for this problem, we have 3 solutions. So at the end of this lesson, you should be able to solve a quadratic equation by factoring and using the 0 factor property.